made mistakes. Okay, now let's take a look at the next question that we have. The question is asking, which of the following could be the equation of the function? And they give us some options here. So let's take a look at the graph and let's look at some points of interest. So we see when x is equal to 0 on the y-axis, the y is equal to what looks like negative 1.5. So let's write this as a point like this, xy. Whoops. xy. One of our points of interest is 0 and negative 1.5. Let's find another point of interest. When x is equal to pi, we have y also equal to negative 1.5. Now with these 2 points of interest, we can kind of sub these into the other equations and we can see who works and who doesn't work. Okay, but first let's take a moment to think about this. So we see all of our options are cosine functions and they all have a coefficient of 0.5. So we can't disqualify anyone based on that, but we can look at the end. See how this is like minus 2 plus 2, minus 2 plus 2? Typically a cos graph looks like this. Or actually, I can even pull up my Desmos, my graph. Let's do cos x. Typically, it looks like this. It will start at 1, and then when x is equal to 0, y will be 1, and then, you know, it goes down and it waves around like that. This is not at 1. So this is below 1. So if we were adding, we would be moving the entire wave upwards. So we need a minus term for it to move downwards. So A and C can be disqualified quickly just off the fact that they have plus terms at the end. So we know that not A, not C. So we have to check between B and D who works out. Well, we can just we can sub in our points of interest and we can hopefully find out. So let's try with B first. So B is y equals 0.5 cos times 4 times x plus pi over 2 minus 2. So let's sub in our point of interest, pi and negative 1.5 for y. So we have negative 1.5 equals 0.5 cos 4 times pi plus pi over 2 minus 2. Let's pull out my handy dandy calculator to calculate the right side of this equation. So we have pi plus pi divided by 2. That guy is multiplied by 4. And we're going to need to take the cosine of that. So I have to set my cal to radians. Do that super fast. So the cosine of 4 times, I guess 3 pi over 2 is 1 times 0.5 is 2. And then, I mean, it's not 2, that's a 0.5. Minus 2 is negative 1.5. So we're probably good on that, but that doesn't necessarily mean that we can disqualify it. Actually, instead of subbing things in, we should see that, you see this term, we have like a 4x term. Okay, so it turns out for both B and D, if we sub in our points of interest that we got off the graph here, we will see that they both actually work. Now, a thing to note is that typically one period of a cos, meaning like it goes all the way down and all the way back up, is going to be 2 pi. But here, it goes up and down and up and down. So in a single pi, there are 2 whole periods. So that means it is going 4 times faster than just regular cos. So that means that we have, it's going to be the thing that's multiplied by 4 instead. Because we know that it is going 4 times more frequently than it would be regularly. Normally, you would only have a half period at pi. You see here, pi is halfway through the entire wave cycle, but a full wave cycle is 2 pi. Now, in 1 pi, so that's half the distance, we have 2 full waves. If we had 2 pi, there would be 4 full waves. So this is going 4 times more frequently than it should be, which means that what's inside of the multiplication here, it should correspond to multiplying by 4. So let's actually stick this equation into Desmos and see if it lines up. So it was 0.5 times cos, it was 4x. You see, if we multiply by 4, how much more frequent the graph gets. It was 4, and it was x plus pi over, I think it was pi over 2. Yeah, pi over 2. Oops, pi over 2. Get that bracket in there, and then minus 2. So our points of interest, are they here? Pi and negative 0.5, 0. And look, it matches with our points of interest. We have a peak at 0, a peak there, and a peak at pi, like one peak in between pi and 0. So that matches up. Let's see D. If we plot D, we should see that this is definitely not the same. So I'll plot that. 0.5 cos, 0.5 times cos, 2 times x plus, I think it was x plus pi, x minus pi, x minus pi, minus 2. Hey, well, you see for D, when we have the factor of 2 out here, it's not frequent enough. So we have to disqualify D on that. Because it's going 4 times more frequently than it normally is, we keep in mind the 4. So, yep, it's the term that's multiplied by 4, so that's good. And since we're multiplying by 4, it's going 4 times more frequent, meaning that it's compressed by a factor of 4. And we sub in the values. So the choice is B, and there's a big detailed explanation on that with some more, I guess, formal mathematics about like how you can change the phase and or the compression term. And here, multiplying by 4 compresses the entire graph to be 4 times more frequent than it is regularly with just like cos x. So the above solution is correct. Awesome.